All right, so let me control it. Okay. Now the question, if I convert or replace this orifice, okay, with flow control valve, like these three orifice, if I change it to flow control valves, so the pressure drop value, what we are seeing now, 0.43, 0.2, and 0.16, right? So the delta P would increase or would it decrease because we are using flow control valve?
Delta P will increase now.
Delta P will increase. Okay, Shankar
Yes.
sir, what do you think?
Delta P will increase.
Okay, 2 increase. Votes. What about others? Madhu ma'am? No idea. Ma'am, the question is clear?
Sorry, sir, I didn't listen. Can you please repeat the question?
Okay. If I replace this orifice with flow control valve,
Orifice with flow control valve.
yes, so the pressure drop in that case across that control valve would be, say for the first one, will it be more than 0.43 bar or it will be less than 0.43 bar?
Will be more than 0.43 bars.
Okay, so 3 votes for more. Anyone else would like to answer that? Yakesh,
Yes, sir.
more or less?
Couldn't say, sir.
Why? You had to take a guess. And that should be calculated guess.
Yes.
Chirag, what do you think? Or you already said? So when we started, what was the flow rate in the first loop? 136 meter cube per hour, right?
Yeah. Yes.
All right. So what exactly we did? We used orifice because the first loop had a lot of energy in it, correct? So we just killed that additional pressure with orifice, right? Meaning, if I kill the 0.43 bar in the first loop, then the flow rate in the first loop will drop from say 136 to 100 meter cube per hour, right? And that delta P has happened because of orifice. Do you really think that the system would really care if how the pressure is being reduced with orifice, with manual ball, glow ball, or a flow control ball?
No,
Will it really matter?
doesn't matter.
It doesn't matter, right? So you have selected all the 3 orifice, then right click on one of the orifice.
What?
You have already selected 3 orifice. You need to right click on one of the orifice. Then there is change component. Click on change component. First one. First. Yes. If you scroll little down, you'll find flow control valve. Flow control valve. Then click OK. So the orifice has been changed to flow control. Right? So while you are still at input, we can have the properties also. Click on the input in data palette. Alright, so automatically size will make it off. Off. And the flow rate, design flow rate we want of course 100, so that will remain same. Wall model, do you want 2-inch butterfly wall or 2-inch wall in 5-inch line? Does that make sense?
No.
No, right? So one size less or two sizes less. So the line size is 5-inch, so 3-inch butterfly wall would be a better option. Butterfly wall because for water services we usually go for butterfly walls. So go to wall model. Instead of 2-inch butterfly wall, you go for 3-inch butterfly wall. Scroll down. 3-inch butterfly wall. Then click OK.
Right to put it.
Then go to properties. make it show. Then go to properties. Yeah. So we want to know what is the wall opening and calculated CV and friction loss. Yes, Mr. Mark. Go to the properties.
Yeah.
So all these things you are going to get it in results. Calculated CV, friction loss, F, friction loss, go up, 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 friction loss. Okay, then go to the last wall opening. Go to the last, extreme last wall opening. So these three information we need. Click OK. All right. Let others also complete this. Then you can click on calculate. All right. So what do you see there? Any change in delta P?
No.
There should be no change in delta P. Because if you increase pressure drop, then the flow would reduce and vice versa. Okay, if you click somewhere else on the flow sheet, you see that the second and third control wall are red. Okay, so what is the problem? You can check the messages. It says wall position is greater than maximum limit. So what is the wall opening for second and third? 76 and 78. So we know that as long as it is less than 80%, we are okay, right?
Yes,
So
Yeah.
why this fellow is having problem? Because in fluid flow, the limit set is between 20 to 75%, but we can change that limit. If your vendor says that this particular wall can go as high as say 85 or 90, we can always change the number. So you see on the top right side, there is System International. System International. Don't click there. On the right side of that, there is yellow. One arrow is there, yellow, extreme right.
warning and
So
hints.
right. Yeah, warning and hints. Click on that.
So,
Go to liquid limits. So there you would see minimum operating control wall 20 and maximum operating control wall 75. You can change that 75 to 80. Then okay. Since you change the input, you need to calculate again. So this time that warning will go away because the wall opening is less than 80. Ma'am, you said something?
sir, how did these two valves turn red, sir?
Because fluid flow default maximum control wall opening is 75%. So since it is exceeding that limit, that's why it is red. But we can edit that. As I was telling, if you go to hints and warnings, you know where it is?
Actually, it didn't turn red in my sheet.
What is the wall opening?
Yes, sir.
Hmm?
Yes. For me, the valve opening, it was one is 66.7, the other is 75, next one is 78, 77, but it didn't turn red for me, sir.
Okay, you click somewhere else on the flow sheet.
Oh, yeah.
All right. You know how to increase the limit, right? From 75% to 80.
Can you
You
explain
see
it?
this? You see this warning and hints?
Warning and
Yellow.
hints.
You
Yes,
click
sir.
on that. Then go to liquid limits. So instead of 75, put 80% and then click OK and run it again. Clear?
Yes, sir.
All right. Any query on this problem?
Yeah,
Also,
but
when
excuse me, please. If the flow is varying, where does the control valve take its signal from? From the pump?
It will have See here, what we are trying to do in this particular problem is we want to make sure that flow rate is 100 meter cube per hour. But in the real world, the control valve will be on the cooling water side outlet, no doubt. But it will be controlling the temperature. So the process side outlet temperature, there will be having temperature transmitter, and that will give signal to this TIC for this control valve. It's basically a temperature control valve, not flow control valve. But anyway, if we already decided that the flow rate is say 100 and the design flow rate is 100 meter cube per hour, so we can use this to find out what is the CV, what will be the wall opening if you choose to use 3-inch butterfly wall. All right.
What is the advantage of using the butterfly valve here, sir, when the orifice is much cheaper than control valve?
This also I had explained. If the flow is not means the process side flow is more or less same, okay, in all the cases or all the scenarios, then you have to use flow control valve. You can get away with a restriction orifice. Now just imagine that sometime we are running the plant at 100% capacity. So that time probably the flow rate or the net flow for the cooling water is say 100 meter cube per hour. If sometime we run the plant at say 50% capacity, right? So that time what will happen if I have the restriction orifice? So do you think that the flow rate will reduce to 50? No, it won't, right? So that time we'll end up providing more water. So the process side also, the temperature will be on lower side, which may not be accepted, right? So for that, if you have the flow control valve, then it will work fine. But yes, it is expensive. That we cannot avoid it, right? So we need to actually check.
It's once in a while now. It's a project. It's something you put at the installation, after which it's just maintenance.
Correct.
So it's okay.
All right.
As
So in
long as see what you
the
want.
project what we had done for Bharat Oman refinery, so they didn't have any this glow ball also for throttling purpose. They had the gate valve for isolation. So the gate valve they are not fit for throttling. So that's why they could not maintain. They wanted to reduce or increase, but it was not really happening. Okay. All right. So let us proceed.
One more doubt.
Yes, sir.
What if we have the control wall or the restriction or base before exchanger? Will work fine.
Typically, it will be on the downstream of the exchanger. The reason being, if I keep it on the upstream, then there is a chance that I'll starve this exchanger for the water or whatever fluid it is there. So maybe if the water is going in the shell side or the tube side, so there is a chance that the shell side or tube side will not have full, liquid. The tubes will be filled with this liquid or fluid, basically. Right? So there could be chances of overheating or some hotspot might get generated. So because of that, we'll always keep it on the downstream, so that even if there's get throttle, upstream system, that exchanger will be always filled with our liquid. That makes sense?
Yes, sir. Yes. And one more doubt, how to make the nodal pressures? So
How to make the?
how to see the nodal pressure points?
Nodal pressure, meaning this pressure?
Yes.
So it is there. Channel stagnation pressure is there. Then, so this pressure is available, right?
Okay.
Okay, it will be available for all the. There is this out stagnation pressure, in static and stagnation pressure. So if you compare, there is not much difference in stagnation and static, because velocity head v square by 2, that value in bar is going to be very negligible, right? So that's why this fluid flow competitor, they don't really care about static and stagnation pressure. They just say that it's pressure.
Okay.
All right. So any query? Any further query on this problem? Okay.